Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, till now we have just discussed about future engineering, mainly related towards the data on categorical data and numerical data. Yes, here today we are just going to discuss on future scaling. Yes, dear friends, when dealing with the numeric futures, we have specific attributes which may be completely unbounded in nature, like view counts of a video or web page hits. So, using raw values or using raw values as input futures might make model biased towards futures having really high magnitude values. These models are typically sensitive to the magnitude or scale of futures like linear or logistic regressions, and other models like tree-based models or methods can still work without future scaling. Okay, however, it is still recommended to normalize and scale down the futures with future scaling, especially if you want to try out multiple machine learning algorithm on input futures. And yes, of course, dear friends, we have already seen some examples of scaling and transforming futures using this log and box cost transformation earlier in this series. And in this section, we are going to look at some popular future scaling techniques. Okay, so yes, let me load now some dependencies and configurations. Okay, so loading the following dependencies and configurations as mainly for sklearn. This is pre-processing. Towards we are just going to discuss on standard scalar, minimax, and roboscalar. This is the most popular futures, that is future scaling techniques. And here we have used NumPy and pandas for data processing. Okay, so next, once loading the dependencies and configurations, let me load some sample data of users. Actually, here we are just going to include only the data, but we want to name it as like yes, it is a data of user views pertaining to some online videos, just to have an example. Okay, so here yes, views is our data frames, and here we are going to have 5 data values, and we are going to specify it as like a views. Let I execute this. So kindly just have a note. So this is what our data. So from this data frame, we can see that we have 5 videos that have been viewed by users, and the total views counts for each video is depicted by the future views. And it is quite evident that some videos have been viewed a lot more than the others, giving a rise to values of high scales and magnitude. So kindly just observe, dear friends, see here, this exact value is, of course, this is 5 and 1, of course it is in ones value, and this is 25, it is in tens, and towards the measurement of 300, it is in hundreds, thousands, 10,000, so everything are in different scaling. So let me look at how we can scale this futures using several handy techniques is there. And yes, first of all, we are just going to see on this standard scalar. Dear friends, this standard scalar tries to standardize each value in a future column by removing the mean and scaling the variance to be 1 from the values. So this is also known as the centering and scaling, and that can be denoted mathematically. Kindly just observe xi minus mean divided by standard deviation. And yes, dear friends, this xi when on subtracted by the mean and the resultant is divided by the standard deviation. See, this is also popularly known as z-score scaling. You can also divide the resultant by the variance instead of standard deviation if needed. Okay, so let me just achieve this by using this code snippet. So kindly just observe, we are making use of this standard scalar and making it as a variable ss, and let me just fit that transform by using this views. Of course, the views, it just comes from here towards this table. Okay, so this is what the views here we have, and let I just execute and apply it. So see here, dear friends. So this is what we are just able to get the score. And we can see the standard and scaled values in Z score column, which is presenting towards this data frame. And in fact, you can manually use the formula we used here towards compute the same result as like mathematically, which we just say is that score. Okay, so that I just want to make it here. Kindly just see here mean by standard deviation, each and everything. If you want to, for an example, if it is a 0, yes, we can make use of that and calculate here. So what it just comes, yes, it's comes here as minus 0.3072. Yeah, that is what we just got here. Okay, yeah, individually you can just also make use of it for anything manually. If you want to identify something, yes, you can just make it, and you can also use that it's a score. Okay, now next we are going to discuss on minimax scaling. Yes, dear friends, with minimax scaling, we can transform and scale our future values such that each value is within the range of 0 and 1. However, the minimax scalar classes, that is also, yes, of course, also use this scikit-learns and also allows us to specify your own upper and lower bound in the scaled value. That is the range using this future range variables. Okay, and yes, when we just see on towards this mathematically, yes, here xi minus minimum of x divided by maximum of x minus minimum of x. Yes, of course, when we just specify it here, yes, we scale each value in this future x by subtracting it from the minimum value. Okay, by subtracting it with a minimum value in the future minimum of x and divide the resultant by the difference between maximum and minimum in the future, that is max of x minus minimum of x. That is what how we just specify in mathematical. Okay, now let me just apply it with a formula and towards the exact same score. Now let me just observe here. So yes, dear friends, this is what the exact views, and yes, we have calculated the Z score by using the standard scalar, and here we have calculated the minimax. So the preceding output shows the minimax scaled value in the column as expected. Okay, so the minimum viewed video is here. So when we just have this, so see here, this is 2, and here we just have the 1 value indexed 2, which has a value 1. So this is what the maximum viewed, and when coming towards the minimum viewed in this row, yes, we have 4, so which is 0 0 0. So here within the range of 0 to 1 only we are just able to make this. Okay, so yes, you can also compute the same thing mathematically by using an functionality each and everything. If you want to make it separate or that is individually also, yes, you can have. So kindly just observe, that is view of 0 minus, so you are just taking only the one single value and subtracting it with the minimum and dividing with the difference. Okay, difference of minimum and maximum. Can let we just have it. So yes, of course it is 0.068. so let I just scroll it again. Yeah, so here we have the value. So this is what. But here, when on using this minimum maximum, minimax, okay, yes, of course, the disadvantage of this minimax is that often the presence of outliers affects the scaled value for any futures. So roboscaling tries to use specific statistical measures to scale futures without being affected by the outliers. So it is very, very much important. So yes, dear friend, when we just go towards this scalar mathematically, so kindly see here, we can scale each value of this x by subtracting the median. Excuse me. So kindly just observe, it is median. Okay, so median of x and dividing the resultant by IQR. Yes, of course, it is interquartile range of x, which is the range, that is difference between the first quartile and the third quartile. So of course you already know about that is 25th percentile and 75th percentile. Okay, so yes, let me just apply this on towards the code. So see here, we are calling upon this method roboscalar, and here we are fit transform towards it, and let me just execute it. And yeah, here we go, and we are able to see it. So yes, the scaled values are depicted in this robust column, and you can compare them with the scaled futures in another's, that is other columns also. And you can also compute the same using mathematically. Anyhow, I just show you this mathematical. Yes, we are going to have this percentile of this quartiles, 25th percentile and 75th percentiles, and here we are calculating the IQR by quartile 1 and 0, and when on just making it, so see here, we are getting the first reading 1.092. So that is what the individual, of course you can also calculate this individuality. Okay, so here we have the first row value. So yes, dear friends, so these are several techniques for this future scaling, and of course there are several other techniques for future scaling and normalization, but these should be sufficient to get you started and are used extensively in building machine learning system. Always remember to check if you need to scale and standardize futures whenever you are dealing with a numeric future. So yes, dear friends, so here we just stop with this session, and yes, next towards one more session is there on futures, future engineering. Yeah, that is on future selection. Yeah, it is going to be in the next video. And yeah, kindly just like, if you are liking this video, put a like, and subscribe the channel if you not yet done, and kindly share with the others, those who in need of this machine learning series. Yes, see you dear friends, and happy learning.